Welcome back to the channel. Today, we're addressing the misconception of antisocial behavior and explaining why the desire to isolate is tied directly to your default mode network and dopamine regulation. If you enjoy deep dives into human psychology, please like and subscribe to the channel. For most of human history, isolation was a direct threat to survival. Our species relied on group cohesion and interpersonal cooperation to acquire resources and stay alive. Because of this evolutionary baseline, the urge to separate from the group was historically classified as dangerous and maladaptive. This bias led early clinicians to view all social withdrawal in a negative light. Today, modern psychology parses withdrawal into specific motivational subtypes to correct that error. On the negative end, we have shyness, which is driven by an internal conflict of fear and social anxiety, and social avoidance, which is an active, profound aversion to peer interaction. But developmental psychologists identify a completely healthy alternative known as unsociability. An unsociable individual does not fear socializing and can interact competently when required. They simply possess a non-fearful preference for solitary activities, finding a higher intrinsic reward in quiet introspection or manipulating objects alone. The objective physical state of being alone is completely separate from the emotional distress of loneliness. They are entirely different psychological phenomena, and treating them as the same thing ignores how the brain actually processes social input. While loneliness is the distress caused by a lack of desired connection, researchers have recently defined its exact mirror image, aloneliness. This is the psychological dissatisfaction and distress that arises from an overabundance of social interaction relative to a person's baseline needs. Depriving someone of the solitude they require yields immediate, measurable damage. High levels of aloneliness correlate heavily with increased perceived stress, depressive symptoms, and irritability. In studies monitoring interpersonal frustration, individuals suffering from a deficit of solitude exhibit significantly higher aggressive tendencies toward romantic partners. To quantify this, researchers utilize the Solitude and Aloneness scale. When testing diverse groups, the data revealed a critical distinction. Time spent physically alone only predicts depressive symptoms in individuals who do not want to be alone. For those craving time away from others, extended physical isolation has zero association with depression. The pathology of social withdrawal does not stem from sitting in an empty room. The damage occurs when there is a severe misalignment between the environmental demands placed on an individual and their intrinsic requirement for restorative quiet. To understand the mechanics of why healthy solitude works, we look to self-determination theory. This model differentiates between two states: controlled solitude, where an individual is forced into isolation by geography, peer rejection, or internal guilt, and autonomous solitude, where the isolation is volitional and intrinsically motivated. When an individual actively chooses to spend time alone, they are acting as the causal agent of their own self-regulation. Paradoxically, choosing to isolate for autonomous reasons actively lowers reported loneliness and significantly increases overall life satisfaction. This conscious choice triggers a physiological response. Psychologist Dr. Thuy V. Nguyen isolated the emotional mechanics of brief periods of isolation, discovering the deactivation effect. She found that taking as little as 15 minutes of device-free solitude acts as an internal affective thermostat. Look at this animated diagram plotting human emotion. The vertical axis represents high and low arousal, while the horizontal axis tracks positive and negative emotion. During the deactivation effect, data points in these upper high arousal quadrants, anxiety or excitement, rapidly drop. The top quadrants empty out entirely, leaving a cluster of stable data points in the lower right, the exact zone of low arousal calmness. People who actively seek out solitude are not avoiding reality. They are intuitively leveraging this deactivation effect to dial down external overstimulation and force their nervous systems back into emotional homeostasis. This psychological preference for socialization versus solitude is physically anchored in the brain's baseline cortical arousal and its sensitivity to specific neurotransmitters. Extroverted brains operate with a high threshold for dopamine. Relying on the mesolimbic pathway, they require constant, rapid hits of high sensory input and novel social interactions to feel neurologically energized. Introverted brains are the exact opposite. They are highly sensitive to dopamine. Standard social interactions trigger a massive dopamine release that quickly pushes them past their optimal arousal capacity. The result is cognitive overwhelm, leading to the profound exhaustion known as an introvert hangover. We can see how solitude seekers compensate in this split-screen comparison of the brain's neural pathways. While the extrovert side relies on rapid, bursting pulses of dopamine along the mesolimbic pathway, the introvert side relies on the acetylcholine pathway, rewarding quiet internal focus. Operating this system carries a heavy metabolic cost. Routing social data through complex centers means navigating a crowded room drains massive cerebral blood flow from the prefrontal cortex. Solitude is a strict biological imperative for these individuals. It is the only way to halt the excessive metabolic drain on the frontal lobes, allowing the brain to switch out of a taxing, stimulus-driven state and begin acetylcholine-based restoration. There is a persistent myth that the brain simply shuts down when disconnected from external tasks. Modern cognitive neuroscience disproves this through the discovery of the default mode network, or DMN. Removing external stimuli clears the neurological bandwidth required for the DMN. Once quiet, this massive system synchronizes and pulses into dominance. The DMN is divided into highly specialized subsystems. Areas like the medial prefrontal cortex and posterior cingulate cortex utilize physical solitude to retrieve episodic memories, generate creative flow states, and process the heavy backlog of emotional data accumulated during the day's interpersonal interactions. The urge to be alone is a subconscious drive to activate the default mode network. Without the interference of external social processing, the brain is finally able to foster metacognitive humility, extract wisdom from recent events, and consolidate personal identity. The deepest differences between forced isolation and healthy solitude emerge at the level of threat detection, monitored heavily by the amygdala. Because forced isolation is an evolutionary threat, chronic unwanted loneliness acts as an acute biological stressor. It traps the amygdala in a state of hyper-reactivity, flooding the body with cortisol, generating systemic inflammation, and accelerating neurocognitive decline. Autonomous solitude behaves as the neurological antidote. By freely choosing to step away, you reduce external data processing. This allows the prefrontal cortex to exert inhibitory control over the amygdala, shutting off the release of stress hormones and preserving the neural pathways required to establish social trust. Solitude is not an antisocial escape from reality. It is a highly sophisticated evolutionary adaptation, ensuring that the human mind retains the physical capacity to repair, reflect, and regulate itself amidst the chaos of social existence. Thank you for your time. We hope you learned about the science of solitude today. Please like, subscribe, and engage in the comments. Until next time, this is SM Says signing off.